Thank you. Cool. So I was here almost exactly 5 years ago. It might have actually been May 2009. I tried to look on my calendar. I couldn't find it. It's so far back. And I was introduced by this guy, and he said, you know, replicators start here. And that was before we even called the MakerBot a replicator. And so I thought, okay, like I watched this morning. I was like, this is kind of like a really neat full circle moment, because 5 years ago, we were three guys, a laser cutter, and a dream. And we'd gotten ourselves into, you know, we really thought 5 years ago that we had started a business that we could do in like 10 or 12 hours a week on the side. And we probably had 2 employees, so there were probably 5 of us at that point. And now we're 500, merged with a public company. And things that, you know, this is what a 3D printed bunny looked like on a MakerBot at that moment. And we were so proud. we were like, this kind of looks like a bunny. This is great. And now we have, you know, 100 micron layer resolution, and it's kind of absurd that it works. And a MakerBot replicator will go head to head with a $300,000 mainframe size machine and kick its butt. And they're being used by they're just being used by basically like any company that does product design probably has a MakerBot. Car companies, phone companies, basically anybody who's making stuff can uses a MakerBot, and it basically takes the way you used to do it and smushes it up. So the way people used to do product design is they used to have an idea and then make a design and then send it out, and it would take like 3 weeks or a month to do an iteration. You'd get it back and you'd be like, the ears are too long, or this needs more cowbell, or whatever you wanted to say. And then you do it again, and with a 3 or 4 week turnaround time, you could iterate like multiple times a year. When engineers get a MakerBot and they put it on their desk, they iterate multiple times a day. So it means, 1, because it's affordable, and because 2, the material's affordable, and 3, we've made it easy to use, good UX, UI, which nobody, probably this is the best room that understands how important UX, UI is. Anyhow, it basically makes it so that people can, they can try things out, they can explore, they can make something, and they don't even have to show their boss if they don't like it. They can just be like, oh, this was a bad idea. Chuck it under the desk in the bin, do it again, do it again. It's not a problem to try again. And that's probably been one of the coolest things to see as we've grown the company, is watching all of the awesome MakerBot operators in the world take the technology and do way cooler stuff than we could ever have imagined. So when we talk about MakerBot, we talk about being an innovation company. And you know, I talked a lot about what companies do with it. The cool thing is it's affordable enough that, you know, when we started, like, it was seriously just like early adopters. Googlebot 2 of the first batch. Thank you for supporting us back in the day. And now it's ordinary people who just need more brackets for their kitchen will get a MakerBot. All of it has to do with innovation, and we like to say we're an innovation company. We innovate so that everybody else can innovate. And back in the day, you know, this is the way if you wanted to make something. This is an injection molding machine. It's probably a 210-ton press. And pellets go on one side, and there's a big, you know, basically 2 big pieces of metal that are a mold that go with that kind of noise, and cranks out plastic stuff all day long. About 40 or 50 MakerBots will compete with that, just for fun. But now you can have, the way it used to be is, it was just a lot of infrastructure. You had to be a tycoon to own that kind of infrastructure to make things. Now you just need a frickin' laptop and a MakerBot, and game is on. So when we talk about leading the next industrial revolution, the first industrial revolution was really around the factory, moving from everybody working on stuff in their home to everybody going to the factory, centralized manufacturing. And it allowed everybody to have things like spoons. Well, I'm sure people had spoons beforehand, but you could produce lots of spoons at one time in a factory, or garment making and all that kind of stuff. Second industrial revolution had to do around, is officially classified as being around the railroad and transportation. So when we talk about the third industrial revolution, I like to talk about all these tools basically being on your desktop, the tools of manufacturing. A MakerBot is a manufacturing education in a box on your desktop. And we've been doing it for 5 years, and so we built out this 3D ecosystem. It's interesting, we actually, we started Thingiverse. Thingiverse.com is our website where people share digital designs, and we started Thingiverse before we started MakerBot, actually. And I'll talk about that more later, but we've got all this stuff around the 3D printer, and in some ways, sort of getting a 3D printer is sort of your ticket into this whole world that we've created, and that's just way more than just the 3D printer. But the 3D printers are cool. These are our 5th generation machines. Something about having a black background and black machines, I think I just didn't do it justice on this slide. Important thing you would need to know is that there's a small version, a medium version, and a ginormous version. The MakerBot Replicator Mini makes things that are about 4 by 4 by 5 inches, so stuff that you might want to at home, or you could make for your kids. MakerBot, we're exploring the frontier of consumer 3D printing, where ordinary people just make stuff instead of buying stuff. This is our sort of adventure, and the MakerBot Replicator Mini is really our sort of step into the adventure of making something for people who aren't engineers. One-touch 3D printing. The MakerBot Replicator, which I've got up here, is 5th generation technology 2. It's basically optimized for the engineer, the industrial designer, the architects of the world. And the MakerBot Replicator Z18 is ginormous. Build volume is 12 by 12 by 18 inches, so full size. If you need a full-size replica of your head, we're on it. What's interesting is anybody who's had a 3D printer or used 3D printing before wants this one. All the orders for this are people who already have 3D printers. It's interesting. So it's it ships in May, or officially in spring, so I can be flexible if I need to push to June, but it should be May. And it's going to be super interesting to see what people do when they have, big scale 3D printer. And to get one of these, it's like the best volume to price ratio if you want to geek out on how awesome it is. It just blows everything else out of the water. The cool thing is, though, is that even though we just came out with 3 new 3D printers, it's kind of like we just came out with one 3D printer, but in 3 different sizes. They all have an onboard camera. This means that you can pull it up on your phone and watch your model being made from another part of your house or the world, or if you're on a space station, then fine. They all have this smart extruder, which just swaps in and out. So if you need to replace it, or if you need to, and it's got a little brain in it, so it knows when you run out of filament and sends you a message saying, "I'm hungry." And they're all app and cloud enabled. I'm sorry, this is an iPhone, not an Android device. It's Android. The mobile platform launches in about a month and a half, and Android will follow shortly after. The MakerBot Replicator and the MakerBot Replicator Z18 both have this super luscious LCD display. And there's nothing like going from the MakerBot Replicator 2, which is our 4th generation machine, has a little alphanumeric display. And I gotta say, it's like we're moving from flip phone technology to smartphone technology. It's that big of a leap. I'm like, yes, more than whatever it is, more than 100 characters, awesome. Pictures, yes. So So the small one is, like I said, it's for beginners. It's got all the same things that all of them have. It doesn't have the display, but you basically use your phone as the control mechanism for it. And the MakerBot replicator, kind of getting redundant here. Huge build volume for engineers, industrial designers, architects, and then this giant one's just out of control. This has a heated build chamber to reduce curling. If you've done 3D printing, you've battled curling. I can't say it makes it go away, because it's something that happens when you use a thermoplastic where you heat it up and you extrude it. It's like the way it works, if you haven't seen one, is it basically draws a picture in plastic and then draws another picture on top of that, and layer by layer it makes your model. When you do really big things, all thermoplastics shrink when they cool. And if they curl, and while it's being made, it kind of curls up at the edges. So we've done a lot to reduce that with this machine in particular, because with big things it's more important, because like if it shrinks 0.2%, it doesn't really matter if it's just like 3 centimeters long, but if it's 25 centimeters long, you've kind of got a problem. So we make these in Brooklyn. Can we give it up for New York City? Yeah. So this actually is really important. We did a lot of research into making them all in all sorts of places. And it came down that for us, it was most important that the manufacturing engineers, the design engineers, could argue in the same place. And so we've got a facility in Sunset Park where we've got a really ginormous factory where we just crank these out all day long and ship them. And it's interesting, like, I think when you do a hardware startup, you have to love packing and shipping. If you don't love packing and shipping, like, go into software. Well, you have to ship in software too, but it doesn't involve like, well, I guess it does sometimes involve physical stuff, but it's different. We love to pack and ship, and it's funny, when we started, when I was here 5 years ago, I did everything with my partners. We did everything. We laser cut the parts out. We called the suppliers and grumped at them if they were late. We packed all the boxes, put the stickers on them, loaded up the UPS trucks, and now I have a whole team that just loads UPS trucks. It's awesome. It's one of the great things about growing is that you're like, okay, I don't have to do it all anymore. We get to have teams of people do stuff. So this is on our assembly line. So what you can see here is that there's parts for the MakerBot that come down the assembly line, and they come on these sort of like cafeteria trays, and attached to the cafeteria tray are all these jigs and fixtures made on a MakerBot. There's more than 1,000 jigs and fixtures at the MakerBot factory, which are parts that we use made on the MakerBot to make MakerBots. And this is actually one of those things that 3D printers and MakerBots in particular are going to get used for, that is not as like high profile, but is deep. Manufacturers in general, when they make jigs and fixtures, generally have like a carpentry section, and they just basically set people up they set all their stuff up, and instead of having these 3D printed parts, it's usually like pieces of wood kind of hammered together. It's very piecemeal. This is just so much easier than doing anything else. I mean, the other alternative is to take like a material like Delrin and mill it out and make these things. But when you start realizing how much it costs to get time on a milling machine, it's just like this is, if the manufacturers hear this and watch this Google Talk video, then and their ears get pricked up and they get it, then our biggest customer may not actually be consumers like I'm planning on. It may end up being manufacturers that use this to streamline their manufacturing facility. So we have so you know that hardware doesn't work unless software is great. I mean, that's one of the things that if I'm anywhere and I say that, you all will get this. We've had a lot of knockoffs, and but most of them do not understand that to make some hardware work, you have to make it a great experience for the end user. And that is almost entirely software. And so I love my software teams. And MakerBot Desktop is an application that you download, sits on the desktop, and you get to kind of enter the world of MakerBot through it. You can explore Thingiverse. You can shop in the MakerBot digital store. You can plan your model on a virtual build plate and then send it to the MakerBot and make it a full build plate. Inside MakerBot Desktop application is the Makerware, which is the tool for basically you take it from whatever design tool you use. You can use anything. When I was here 5 years ago, you owned Google SketchUp, so I did a big thing on that. Now you've gotten that out, you've sold that. But really, SketchUp, Pro-E, SolidWorks, Autodesk. Autodesk actually has a great suite of stuff if you're just getting into it with 123D. You can really make, if you want it, there's really no excuse anymore. It used to be you could say, like, well, I don't know CAD. But now the tools are easy enough that you can get into it, even if you've never done it before. Easier than Photoshop is what I'm comfortable saying. We've got it set up with a cloud solution, so you can basically organize all your models. You can organize all the things you've ever made on your MakerBot, so you can see what you've made. If you want to make it again, it's easy. And you do 3D print monitoring from this application as well, and then you can access Thingiverse. So let's see. I'll come back to Thingiverse. Thingiverse may be the coolest thing of all of this. Same thing with a mobile app. You can cruise everything, monitor everything. And then we've announced it and we're about to ship Print Shop. Print Shop is a tool that is really, if you want to design something, we're making a bunch of tools so like you can make if you can type, you can make a 3D model. So you just type this in to Print Shop and it makes it a 3-dimensional sign for your desktop or your door or whatever. And then we've also got a bracelet maker, so if you need to make something for your sweetheart, it's pretty easy. We made it easy. That's the whole idea, is like, so many people, I'm a former school teacher and I taught in the arts, and so many people go through, particularly public school, and come out thinking that they can't do anything artistic because they didn't draw a house the same way that the teacher wanted them to draw it, or they didn't do something the way they got a C+ in creativity in school for something that they weren't even attached to. If we can reignite, if MakerBot can have any part in reigniting even just one person's creativity, I feel like we'll have been successful, because there's just so much that can happen when one person gets engaged, starts having ideas, and starts making things happen. So Print Shop is our answer to get people who are just beginning into this, jump-started into the process of being creative. I've also, I hired this exceptionally badass team of designers that just make cool stuff. So this is, do we have a picture of, oh, we don't have a picture of the, we've just got a picture of the model. This is actually a full-size, realistic samurai helmet, and we've launched the MakerBot digital store to basically make it so that anybody, even if you're not a designer, can just go and buy 3D models, make cool stuff, make your family happy. We're doing entertainment, and the next step we're going to do a bunch of practical stuff. But for right now, you can basically get an immense amount of cool models. And we have a model where you basically pay, kind of like an app store. They're 99 cents each, or you can buy a whole set for $9.99. And then of course, then you can paint them. Very satisfying. So this is a little bit. This is about 2 or 3 months old. There's significantly more MakerBots in the world than this, because we just, like I said, we're packing and shipping like mad right now. And then, oh good, now I'm to the part of now I'm talking about Thingiverse again. So Thingiverse is what happens when you take an engaged community who make digital designs and you give them a place to share things. We started Thingiverse, and Thingiverse is still a place where, it's actually, it's interesting. Archive.org just crawled the site and archived everything. And it's something like I don't know, it's more than 100 gigs of just models. So if you want to so I think if you wanted to make everything on Thingiverse with one MakerBot, it would probably take you like a couple hundred, if not a couple thousand lifetimes. So you should just make the stuff you want. So this is just so cool. This is one of my favorite things to do every day. Is I go to Thingiverse.com, our website, and I'm just like a power fan. I like to look at everything and see what's new in the world that you can make today on a MakerBot that you couldn't make yesterday. And to be clear, we're actually agnostic. If you have a different kind of 3D printer, you can use the same files to do it. There's a bunch of stuff we're doing to optimize it to make it really easy for MakerBot users, but whatever you got, come and share. And if you make cool stuff, share it here if you're comfortable with that. It's a lot more than this now, but there's just a lot of digital designs, and just a lot, like our AWS bill is kind of absurd. So this is a project. This is a RoboHand project. This is, every once in a while I got like journalists asking me like, so you just make tchotchkes, right? And I would have to resist, the impulse to hit them in the face. And then I'd tell them about RoboHand. So RoboHand is a project. It's a collaboration. Two guys collaborated to develop the hand that you see on the screen here for this kid. And it's a prosthetic hand that really anybody can use, but it's optimized for kids. Kids who are born with amniotic band syndrome don't have fingers. They have a palm, but no fingers. And they don't get prosthetics because they grow out of them like sneakers and they cost like 50 grand. So RoboHand is like $5 in material. And it will take you a couple hours to print out. And it's basically great for picking up balls, picking up things, holding a pen. There's a guy, young gentleman who he has amniotic band syndrome. He went to his school. His name's Leon. He used his school's MakerBot to print out a RoboHand, and we were interviewed in the same place, and he was asked, like, so are you going to change it? And he's like, yeah, I'm adding lasers. So this kind of transforms kids' lives from, now they get to go to school and they're like Iron Man. That's Leon there. He's caught a touchdown with this thing. This is John Kemp. This guy is hardcore. He's at Lockheed Martin. He's working on the James Webb Space Telescope project, which is so cool if you're a space nerd. And they realized that they had a problem. They had the space telescope in the cryo chamber. I just like to say the word cryo chamber. Which is a super cold, as close as you can get to Kelvin chamber, with all the air sucked out of it. And the idea is to simulate space. And it stays there for like 6 months or something like this. They realized while it was in the cryo chamber that there was a problem that they had to fix. And there was a chance that with a tolerance stack up, cosmic rays could get into the telescope and ruin the sensor. And so he's holding they went ahead and they made a model. The white stuff that he's holding is a model of the part of the telescope that they were going to have to modify. And the green parts in the photo are the parts that they were going to have to insert, baffles. Now the tricky part is it's way deep down in the depths of it, and they're going to have to like send a little like snake camera down there and use a bunch of tools. So they printed out a replica of the telescope, printed out all the parts that they were going to have to update it with, printed out replicas of the tools they were going to use, and they practiced for a few months. And when it came out of the cryo chamber, bam! I guess it was like a 20-minute procedure. So he reckons it probably saved them 6 months because they were able to do it while it was in the cryo chamber. And there's no official amount that they saved, but it was probably millions of dollars on the project. So cool. And it's interesting. He brought in MakerBots to do this, and he brought in, he's in a cubicle at Lockheed Martin, And people are immediately like, what's that sound? Why do you get a MakerBot? And so they've sort of started proliferating through. And actually at JPL, Jet Propulsion Laboratory, when they have to prototype something and it's within the build volume of a MakerBot, they don't send it out first. They just buy a MakerBot for that engineer because it's cheaper than prototyping one part. And it also is less than the minimum needed for bureaucratic oversight on the credit card. So, pro tip. Uncharted Play. These folks are in Poughkeepsie, and they are awesome. They are making tools for the developing world that basically are cool. This is one of their things. Do I have the? No. They also make a jump rope that when you jump rope, it's got a USB socket on the jump rope, and 15 minutes of jumping rope will charge your phone. Totally. That seems like not a lot until you've actually tried jumping rope for 15 minutes. But this is a ball that has a gyro in it. When you kick it around all day, it generates electricity. It stores energy in a battery, and then you can do your homework at night. You can't really see this photo very well, but it's a shame. Right next to her are two inserts for shoes. And they're like the kind of things you would get like if your feet were messed up and you went to the doctor. What are those called? Orthotics, yes. She's right next to her, two orthotics. She's super happy because she just got back from the amusement park. She's 41.5 inches tall. Those orthotics don't do anything for her feet except make her half an inch taller so she could ride on all the rides. So like, basically, this is a MakerBot dad who's like, MakerBot operators live for this moment. Oh, you're not tall enough? I got that. Casey Hallgren is in New York City. She's a set designer, pioneering 3D printed set design. She's got shows on Broadway, and she's a pioneer in set design. But then having a bunch of MakerBots stacked up in her closet running 3D prints overnight, and then she goes in and argues with the director about what the set should look like. She's also a pioneer. All the stuff she makes, because it's all period furniture models, she's a whole nother business she started at PrettySmallThings.com selling dollhouse furniture. So whatever your passion is, add a MakerBot to it and a little entrepreneurialism, and game is on. Yeah, so cool. She shares these models on Thingiverse too, so if you have a MakerBot, just download them, and when you're shrunk, you'll have good furniture. But Tanti did a project working with students at Pratt. He's a legit, totally superstar fashion designer, and he's making dresses that we actually have one hanging up at our store right now on Mulberry Street, just north of Houston. It's hot. Local Motors is an awesome company that makes desert rally race cars, and they realized that the mirrors were not far out enough on the Rally Fighter. So they on every Rally Fighter, they actually print out little extenders for the mirrors. We see a lot of MakerBots in classrooms, and this is Ryan Kane. He actually has students make houses, prints them out, and he has a whole large diorama set up where everybody puts their houses around, right next to a river, and then they take a hose and run a hose through the river. And the kids learn about erosion by watching their house float away. We're on a mission, actually, to put a MakerBot in every school in the United States of America. We started, and we're actually working on our second stage of basically looking for funders. We basically give an amazing deal to funders who are willing to put who support a teacher in getting a MakerBot, we partnered with DonorsChoose.org. There's actually stuff there now if you want to go up and see if there's a school in your neighborhood or your school you went to that wants a MakerBot. And it's at the teacher's pull, and then they get support. And a lot of times, they don't even need to wait for a funder to fund it. The communities are using it kind of like a Kickstarter for teachers to just get this technology in classrooms. And I would equate it to when I was a kid in 1981, there was an Apple II Plus in my classroom that gave me an unfair advantage over the rest of the world as a nerd. And we're seeing the next generation. There's a different kind of nerd that shows up. We basically, in many ways, we've taken care of most of the computer nerds in the world. So the young people have access like never before, especially in this country. But there's the kids who like to work with their hands. And I'm not sure if you know, maybe you're like me. When I was a kid, I took auto shop, I took wood shop, I took metal shop, and there was even home ec. I liked home ec too. That's all gone. All those programs have been decimated. And one of the cool things is when you put a MakerBot in a classroom, it uses all the technology that's available, the computers in the classroom, and then allows young people to actually do things that are physical, that are real, in real life. And it just activates a section of the population that isn't being served by schools now. So it'll take us 3 to 5 years to do, but I think it's actually, it's going to be one of the things that is that I think will basically be our legacy if we do it, is getting this equipment, getting this technology in schools. So if there's the right person in the room, or you can point me to the right person, I'd love to connect and amplify that with you all. And so you can just go to makerbot.com/academy to learn more. So that's the end of my talk. I've got a bunch of stuff here that I can show you, and then I'd love to take questions. I'm expecting good questions from this audience. So we've got a jet engine. This is one of the designs that chunky trucks that you can buy. It's really awesome, and it's all one print, and it prints without supports. 2-color geometric thing. This is a Voronoi vase. You know what? I actually, there may be some community models here. No, I think this one might be a community model. I'm going to have to attribute this, and in the comments of this video, I'll make sure everybody gets attribution. That's important to me. Really nice bud vase. I showed you the robo hand. This is cool. This is printed in one print, but it prints everything just with enough tolerances away from each other that when you snap it off, it turns into like a necklace. Easter was big on Thingiverse. Oh man, that little bunny. If you got one of these little things that's like a distraction tool, this is a big version of that. It's the exact same model, just scaled up. For the MakerBot Academy stuff, we're creating curriculum. So we also created. So this is the Great Pyramid of Giza. But when you open it up, you can actually see there's a little map in here where you can see all the like secret chambers. We also did a 3D printed dissectable frog, saving frogs' lives, and a chip holder or chip bag holder. So let's see. So I'll stop, I'll say thank you, and then we'll take questions. Thank you very much. You know what, before I do that though, can I just ask, I was here exactly in this spot 5 years ago. I know there's at least 2 people in here. Can you raise your hands if you were here 5 years ago? 1, 2, 3, 4. Oh, that is, what's that?
May 22nd.
That's when I was here, it's May 22nd?
2009. Yeah.
Oh, cool. Thank you. Okay, first question.
Thank you for your talk. I have a replicator 2 at home.
Awesome machine, workhorse.
Yes. So 2 related questions. First is your new printhead, there are problems with extrusion sometimes. And the problem is that you have a long print and it stops in the middle. So your new print head, which is a very low detail here, it just makes sure that if you run out of filament, it tells you. But there are so many other problems. I have a list of things, and it stops printing and it runs, it makes noises and does nothing. Does your new print head actually either stops or actually prevents the problem from happening?
So one of the things about, the Replicator 2 has a tool head that's what's called open loop. So that means that it doesn't have a sensor that knows if it runs out of filament, it doesn't know. It just keeps going. If it gets a jam, if there's a bunch of dust on your filament, it gets it in there, it clogs up the nozzle, it doesn't know. And it's come a long way, actually, from when we launched that print head. But the new Smart Extruder, we've got two different kinds. There's 3 sensors in there. There's a Hall effect sensor to make leveling a lot easier, so it knows where the extruder is in relationship, so that you can make a really nice make the build platform very flat, which is another challenge with the Replicator 2. Very doable. It just takes a little bit longer than you would like. And then we've got sensors in there that both sense whether the filament is there and how fast it's going in there. So that we're trying to address all the things that we wish we'd done back in the day. But there's a lot we've addressed there. Have we addressed everything? I'd love to say yes, but I think we're going to find as we're shipping these that there's probably something that we'll need to do for the next one. The cool thing with the Smart Extruder, though, is it just pops off, and it's held on by magnets. So if and when we ever do an upgrade to the extruder, you can just buy an extruder rather than a whole new 3D printer.
Okay. Follow-up question. If you have a Replicator 2 and you want to upgrade to the new technology, the problem is you have to buy a new stuff from scratch. Do you have any idea for trade-in?
You know, I've got an Android 2 phone that we can talk about.
Well, it's a $2,000 thing. It's not a smartphone. It's a $2,000 for people.
You know, I'm not sure if you were here at the beginning. We've got Adam here. There he is in the back. We do have a special thing for people who are in this room.
Okay, thank you.
Okay. Talk to Adam in the back there. Great. Next up, over here.
Have you done much thought about how this affects things in the developing world context? Because it is transformative, but the biggest problem they have is often just getting the PLA.
Yeah, and then there's also juice, electricity. So there's a group, iLab, that is super cool. They needed umbilical cord clamps. They had a MakerBot. They just make them, and it's now the local supply for umbilical cord clamps. There's huge opportunity there, and there's huge opportunity for people who are connected so that they get there and they can know how to use it, have the resources and enough material. The good thing is actually a roll of MakerBot PLA filament goes a long way. 390 some odd chess pieces from one roll of filament. So in theory, someday you might be able to make your own, but right now the machine that makes filament is the size of a semi-truck, so probably not this year. But there's all sorts of room to innovate there.
Sort of follow on.
Sure.
I've explored a little bit. Is there any hope of getting something to make filament out of PET bottles?
Funny you asked that. One of the challenge so I had an idea when we first started the company to use an apple core to take the bottles and just make strips, and then you could feed in. The downside is that would only work on bottles that are more than 30 years old, because since then they've optimized the bottles, and all the bottles are different thicknesses depending on how much stress they're under. So there is a group, though, this is so cool. There's a group at the University of Washington that entered this contest, or it's the Milk Carton Derby on the Lake Washington, and the idea is you have to make a boat out of milk cartons and race it, and they're pretty loose on what you do with the milk cartons and how you do that. So this group took a bunch of milk cartons, which are made out of HDPE, thermoplastic, and they actually had a really hard time keeping quality because every different kind of milk carton is different. Doesn't necessarily have the same quality plastic. And anyway, they put those literally in a blender and then made an extruder that had a really thick nozzle, like ½ an inch. And then they extruded a boat. And when they showed up, they said, no. This is for boats made out of, milk cartons and milk jugs. And they were like, uh-huh. I think they probably changed the rules next year. But there's all sorts of opportunities there.
Thanks.
Yeah.
So I've got a whole list of questions, but I'll just ask one for now. What are some of the short and long-term issues impeding the progress of 3D printing, and what are you or others in your industry doing to solve them?
One of the biggest ones we've knocked down, we've done. So when I was here 5 years ago, I had to explain what 3D printing was as a concept because nobody understood it. When I talked about 3D printing, I might as well have been talking about, like, I don't know, teleportation or something. Same thing, but yeah. I feel like we've done a pretty good job because we took it on as our primary mission, first and foremost, to educate people about the possibilities of the technology. Now that and I feel like we've done that, actually. I think once we got on the cover of Wired, we were like, okay, I think most people have at least heard of it. Now I think our big challenge is how do we get people to the point where they think it's not just for early adopters, that it's normal to use a 3D printer. So I think that's our biggest challenge, is how to make it, how to educate the public to just be like, I just whipped it up on my MakerBot, no big deal. I want that to be normal. Right now, there's 44,000 or more people with MakerBots who they're already living in that future. And I think sometime this year we'll get to the point where more than 50% of the population knows someone with a 3D printer. How many people in here know somebody with a 3D printer? Okay, for this room, we may have already gotten there. But that's I think the next big hurdle. And that's more of a social engineering hurdle than a technical hurdle.
Could you expand on technological problems you might be facing, not just cultural adaptation ones?
I think the question you're asking is sort of like, can you tell me all the secret stuff you're working on? And the weird thing is, though, I hate to give you a social engineering answer. The other on the technical side, it's actually making it easy. I don't know how many of you are early adopters and have bought stuff on Kickstarter and you get it and it doesn't work. But making things work easily, and this is where I lean on my software department really heavy, is the hardest thing. So good UI, good UX. We take a lot of pride in it. We're working really hard on it. And that, to us, we believe, is the key to unlocking MakerBots for everyone, everywhere.
Thanks.
Sure.
Hi.
Oh, let me come over here and I'll come back to you. We'll go back and forth.
I'd read recently that the core patents around laser sintering have just expired. I wondered if you guys had any plans.
I heard that too. So laser sintering, just for everybody, is where you take a bed of powder and a big laser, and you laser the powder, and it fuses one layer of it, and then you make a very fine layer of powder over on top of that layer, and you fuse it again, and it fuses to the layer underneath. And this is super cool. At MakerBot, we're focused on, where did you go? Oh, there you are. At MakerBot, we're focused on, I'm like, what? We're focused on making stuff that you can have in your living room, on your desktop, that can be truly universal. And with the laser sintering stuff, that powder is so fine that it's really, you have to wear basically a gas mask when you're around it. And I don't foresee a family wearing gas masks to do something creative going to happen anytime soon. So for us, it's not really, I can't say we'll never do it because I never say never, but it's not our primary focus right now. Yeah.
Hi, so thank you for coming. And my question is, are you exploring any new different types of filaments?
Maybe. We have a couple. So we have MakerBot PLA, which is PLA stands for polylactic acid. It's a renewable bioplastic derived from corn, so it smells good when you make things with it, which is, you'd be surprised how important that is, actually. Like, our previous, the first two 3D printers we had were primarily for ABS, and even though we did the tests, and it's not like, it's not bad. It smells like, hot plastic, which is not awesome. Having PLA in your home is kind of like, it's like you're making pancakes is what it smells like. And it turns out that does, like, I think in some ways smell may be one of our most important purchase factors. That being said, we've also got, so we've got ABS, we've got PLA, we've got a MakerBot flexible filament, which is super cool. And then we've got a dissolvable filament, dissolves in limonene, which is like a non-toxic cleaning product. Smells like oranges. Again, smell. There's a whole frontier of different materials, and we have some limitations on how much heat we can have into the extruder, which limits it. And it's one of those things where it's very frustrating. We've done a bunch of research on a bunch of different materials, and we're like, okay, here's a new material. Is it better than PLA? No. And I don't know, like, material science, you're limited, frustratingly enough, to the periodic table. And so, when we find better things, we'll absolutely release them, and it's on our. And I wish I could make that happen faster and find and add elements to the periodic table.
Thank you.
Cheers. Back here.
Hey, so HP announced they would soon enter the market of 3D printing. So I was wondering, what are your thoughts about those, either traditional printing company or bigger consumer electronics company coming into the market, and what's the impact for MakerBot?
So we've been doing 3D printing for 5 years, and Stratasys, that we merged with, our sister company, has been doing it for 25 years. And at Stratasys, we're a unified group of the smartest people in the world pioneering 3D printing. And in many ways, it was so cool to get together with them because all of our engineers got together with their engineers, and we were like, we've got these problems, we're wondering if you have solutions, because you've been at it for like 20 more years than us. And they were like, no, those are just hard problems, we've got them too. So I think that when you think about competition in the world, people entering the market, it's, well, one, it's still so early, so frickin' game on. But I'm not really worried about it. We're an innovation company, we're focused on empowering people to innovate. Yes, over here.
So I have two things. One is a follow-up to the filament question earlier, and
Sure.
there's a separate question. Are you familiar with Filabot?
Yeah.
Okay, so your response didn't seem to indicate that, but sub $600 filament creation from plastic shards, and you can grind up previous prints from your existing replicator.
So, I don't really like to talk trash about anybody. And it's a really cool thing, and there needs to be more of it. In fact, people need to get these, find out that they need a lot of work, and then do the work. And it's a cool project, and people will absolutely do that. It's one of those things, though, that you should look into what you spend on the energy you need to do it. You need to spend like the amount of electricity you pump in to make it happen, and the whole experience and how fast you can make it, and decide if that's where you want to spend your time. The other thing that we obsess on pretty hardcore is ultra high tolerances, and it's both tolerances in terms of diameter and roundness. We have a roundness tolerance, and neither of those things are trivial. And again, our setup for making filament is the size of a semi-truck. So it's not, we're not doing that just because we like big things. It's because we're really obsessed with making exceptionally high quality filament that will just work and maintain high tolerances. So exciting possibilities are out there. I think it's exciting. I think that so many people get excited about recycling filament. I think it's just, it's not a one-liner. It's not a one-line solution.
All right. Separate question is, replicators cost a lot of money. How much work are you putting into trying to get affordable printers out to people? You talk about trying to target schools and things like that, but it's difficult to get these into people's homes if people don't have $2,000 to spend.
How much was your laptop?
My current laptop or my previous laptop?
Let's say previous laptop.
Around $500.
Okay. Well, I guess you could get a Chromebook for like $1 now too, right? So I'm not going to win on that one. You know, we took a product that was $100,000 and we made it $2,000. So 50x reduction in price. It turns out that to get lower than that, it's possible, but there's a few things you have to do that. One, you can go the Raspberry Pi way, which is the way most Kickstarter projects go, where they don't realize how much bill of materials are. And Raspberry Pi is a great computer you can buy that costs $35, and it's at cost. And the company that makes the chip on it wants you to use Raspberry Pis because then you're going to prototype it on a Raspberry Pi and buy that chip. And Raspberry Pis are super awesome. They're empowering people to do wonderfully stupid things that are super innovative, that move the world forward. But they have a motivation to do that. So if you don't mind not making any money or building a sustainable business, you can build a rep wrap, which is actually if you want to get into low-cost 3D printing and you don't mind spending a couple hundred hours.
I have a Prusa. It's kind of broken at the moment, but I have one.
Right. See, that's the trick. And Prusa actually, to his credit, built a platform where you can make your own 3D printer. A lot of them were made on a MakerBot. And, but you pay a price in fussiness, basically, and there's no support to call. So it depends on where the value is for you. I mean, at some point, we may get to a point where the hardware is a commodity. To make that work as a business, we have to figure out other ways to make money to make that work, so I can keep, hiring people. So is that a good enough answer for you? Does that make sense?
Good enough.
I would love to have more affordable 3D. I mean, I believe we are affordable compared to the way it used to be, and I know we have to keep making it more affordable. Yeah.
Thank you.
Cheers.
Hey, 2 questions.
Sure.
First, cool talk. Second, I have like a 300 square foot studio. I don't have any room to put one of these, even if I wanted one.
Move to Brooklyn.
And I kind of do. Is there any idea around like 3D print shops like we have 2D print shops?
So if you come in with a USB stick or whatever, and to our Mulberry store, we'll just make something for you. I mean, we'll charge you for it, but it's cheaper than a MakerBot replicator.
It works.
So that's accessible. You can also go to the workshop.
And the other thing, is there any? I don't have a good intuition for how strong these are. How do you know how do you learn that? Just making stuff that breaks?
Yeah, break it. You'll have to get a MakerBot and build another one. But really, I mean, that's what people. It's surprisingly strong. We built a chain and we hung from it and tried to break it and we couldn't break it. There's some you can. It's a little bit. It has some torsion challenge. If you torsion it, like if you were to take a chain and you were to go like this, you would use less energy than if you pulled on it to break it. And the good thing is basically all the industrial designers are like, oh, I'm not sure if that's strong enough. And then they test it and it's strong enough. So I can say basically it's strong enough. But if you actually want to know how strong it is, yeah, you'll have to break it. And I go for it, please. I encourage, that's how we all have to learn. I mean, I don't have more for you, so you can't break it and get another one. But please, yeah, explore it. Try it out. Over here.
All right. I've actually have a cupcake
awesome.
3D printer, and I really liked it. Now, when the thing you're talking about with having the social or like consumer level in the home, or just something that you would have, I still haven't seen what could potentially make in the future that would justify the cost of even a $500 thing? I've like made like little things, like I made a holder for the Advair for my mom or something, or like something that like a hook to hold headphones and other things like that, and they're really cool. And I can justify that as I bought the printer as a toy to play with, but I couldn't really justify it as I bought it to make this little holder for the Advair. I bought it to make holders for my headphones or something like that. Where do we have to go to get it so that we can make things like that people will be like, okay,
That's my challenge right there. So first of all, thank you for being one of there's not many cupcake owners in the world. So thanks to Google and thanks to you for personally supporting us when we were making our early 3D printers. They were so fussy. I'm so glad we're past that. And I'll probably, so there's all sorts of, so thank you for that. I think I'll throw the question back at you. I would say that while I'm sure there are lots of things that you can make, that like we literally have high schoolers who get MakerBots, go into business and make back the cost of the MakerBot replicator in like a month and a half. Like pro tip, like make phone cases with your school's logo on it. Game on. So there's stuff like that, and then there's stuff like Square. But I would say like maybe you just need to develop a product that everybody wants, and then go into small scale manufacturing, and then use that as a jumping board for something for going big. Do you have kids yet?
I do not.
So I have a daughter who's 2.5, and I come home and she basically says, "What did you make me on the MakerBot today?" I'm screwed. Eventually I'll be like, "Do your homework." But I get to basically be a superhero around the house with the MakerBot, and that justifies it pretty well. Basically being able to make, stuff like coat hooks and fixing the drain when it breaks and all that kind of stuff. But honestly, the stuff I love to make is all the just weird artistic stuff. I just printed out a model of the anti-Kithra device made by Cosmo Wenman, designed by Cosmo Wenman. And it's not a working anti-Kithra device for the other ancient computing nerds in the room. It's a model of what they pulled out of the ocean. Okay, anti-Kithra device is something that they pulled out of the ocean about 2,000 years ago that is a working computer. I think it's got 70 different gears in it, and except for the fact that gears weren't invented for another 1,500 years or used. So it's either there's a time traveler or somebody was really smart. Super cool. Anyway, Wikipedia go get you to Wikipedia. So it kind of depends on what you're passionate about. And I think when people really get crazy with their MakerBot, it's when they find their passion, whether it's a dollhouse furniture like I showed, or starting a business, or getting into something. The quadcopter fanatics on Thingiverse are out of control. There's close to 1,000 mounts you can connect to a GoPro that you can print out on your MakerBot. So I would ask, like, what's your obsession? And then go from there.
I've been doing robotics, right?
Okay, great.
It seems like you're really saying is the 3D printer would be less like the 2D printer where it's something you'd have, and it would be kind of like have the same function of I need to print out the document so I can hand it in at school or whatever. This is more as something to inspire you to do something new and different that you couldn't have done before.
You're hired. Yes.
You.
Thank you. Good.
Let's make this the last question. Sorry.
Sure. So 3D printing is cool because you can print whatever you want within reason, but two groups that might oppose certain uses for it are copyright holders, like maybe Disney doesn't want you to print out a bunch of Mickey Mouses, even though you could, or governments who don't want people to print out like weaponry or guns. So I guess, do you see them as having a legitimate claim to preventing people from printing whatever they want on 3D printers, or like what's your take on those sorts of impediments?
I'll ask you a couple questions and then I'll tell you my answer. First question: did you ever have a cassette tape recorder?
Yes.
Okay. Did you ever have a VHS machine?
Oh.
Right. Okay. Maybe not. A VHS machine.
Oh, yes.
Okay. And then did you ever have a CDR?
Of course.
Have you ever watched anything on YouTube? Bam!
Yes.
So just like YouTube, frankly, we're absurdly DMCA compliant. So it's not going to be that different from the issues YouTube has. And in fact, we get them. Like we have one company that makes little tanks that tabletop gamers, it costs less than $1 in filament to make them on your MakerBot, but when people post them on Thingiverse and they use the brand name, the brand sends us a DMCA takedown, and we're compliant. We comply. And it'll be interesting. So far on YouTube, actually, you've had a pretty interesting ride with this. I think, in fact, you're sort of the test case for this here, in that there's a whole procedure, and I'm not a lawyer, but there's a procedure that once something comes down, the person can say, yo, no, I really did make that remake of Sleepless in Seattle, and it looks exactly like the original movie. Put it back up. And the only way it comes down after that is from the courts. Nobody's taken it that far with things, but it'll be an adventure, and just like we survived cassette tapes, VHS machines, CDR drives, we're gonna explore it and make it work. But
yeah, the guns.
Oh, so the question I think is, what about 3D printed guns? And I get this a lot. And my standard answer is basically like there's way more interesting things that you can make on a MakerBot than a gun, and way more easier ways to acquire a firearm, especially in this country. I think you also have to think like, yeah, I think that, and I think I would just leave it there. Like, and so, yeah, I think that's all. That's all to really say about that. Because, sure, it's super exciting, and there was a moment where like every channel was like, did you know that you might have a 3D printer in your house, and it could do something very scary? News at 11. We had that kind of hype around it, which did a lot to promote 3D printing, frankly. But it's just not our spirit. At MakerBot, we're obsessed with unlocking people's creativity. So it'll be an adventure.
Thanks.
Cheers.
Thanks everyone for coming. Thank you. Let's give a warm round of applause.